Hey guys, my name is Venelin, and in this video I'm going to show you how you can use PyTorch Lightning to fine-tune a transformers model. And this transformer model is going to be ELECTRA, and in the last couple of videos I'm showing you basically how you can pre-process the data for the ELECTRA transformer, and then how you can create your own module and a tokenizer with PyTorch Lightning. And in this one, I'm going to show you how you can use the PyTorch Lightning trainer and train the model. But alongside that, I'm going to show you a couple of tricks. For example, how you can use the warning rate finder and the batch size finder, etc. So these tricks will be hopefully very useful to you as well in your practice, as they are very much useful to me as well when I'm fine-tuning the transformer models in production. So let's get into it. So we're going to continue where we left off in the previous video. And the last thing that we did was to create this emotion classifier, which is extending from the PyTorch Lightning module. So this is basically encapsulating our model. And to just update the libraries, I went to the bottom of the notebook and changed the PyTorch Lightning library and the transformers library. Other than that, we have 1.10 for PyTorch, and I've also changed the runtime type to a GPU, as you can see. And Google Cloud is giving us a Tesla T4, which is great because we need this power to train the GPU itself. And next, I'm going to make a bit of a change into the emotion classifier. We're basically going to find a better warning rate than the one that we are specifying initially. So to do that, I'm going to pass in a parameter called warning rate. And this is going to be a known value by default. So we might not need it every time, especially when we are deploying this model, only for the training part. And here, one thing that I like to do is to import the optional from typing import optional. So this is a typing hint, and this will be a warning rate. So this will be a floating point value. And this import I'm going to change to the top, which we already have this. So yeah, the warning rate is going to be passed right here, and then I'm going to get it and store it into a field of the model class. Yeah. So next I'm going to go to the configure optimizers and specify the warning rate right here. So this will basically allow us to pass a warning rate via the constructor of our classifier. So next we are going to basically create an instance of the model and of the data module that we have. But first I'm going to specify the maximum warning rate, which is going to be 0.01. And the batch size, which is going to be 512. We have a lot of tweets, and the number of tokens that we have per sequence is going to be extremely limited due to the dataset that we have. So we can have a much larger dataset than you possibly could have. So this, of course, depends on the practical problem that you're trying to solve. Then I'm going to specify the data module instance. And this will be emotion data module instance. And here we have the text data frame, the tokenizer, and the batch size. Do we need the batch size, actually? Let's have a look at the data module itself. So yeah, and the batch size. which is going to be the constant that we created. So let me just go through this, and yeah, this is properly initialized. And then the model itself. So this will be the emotion classifier, which of course has a number of classes and the warning rate. So the number of classes is going to be the length of the emotion categories, which again are all of those possible emotions in our dataset. And then the next parameter is going to be the warning rate, which initially is going to be equal to the maximum warning rate that we have. So if we initialize this, you can see that we are loading the ELECTRA small discriminator checkpoint from the Hugging Face hub, and this is provided by Google. So those are the initial weights that we have there. So how we can use this to find a better warning rate than the one that is shown here. So how do we use this in PyTorch Lightning? So PyTorch Lightning has this warning rate finder documentation, and they say that it's basically really important and really hard to find good warning rates. So there is a paper, which basically is this one, which is cyclical warning rates for training neural nets. And this one specifies an approach to finding those warning rates. So what this does is basically try different warning rates and go through a very small subset of the data. And they provide very good examples or experiments in here, and show us that you can basically train much better and much faster neural nets using this approach of finding a warning rate. So these are the cyclical warning rates. So you basically start at some point, increase the warning rate, and then decrease the warning rate, and try this for a couple of cycles, as they say here. And you basically evaluate the performance of the model at different stages, and you do this using a very small subset of the data. So basically this algorithm is implemented into PyTorch Lightning, and I'm going to now show you basically what they do into the documentation here, but I'm going to apply this on our own model. So the first thing that we need is to create a trainer, and the trainer is, well, as you can possibly guess, the driver behind the training of our model. And here I'm going to specify the number of GPUs. So we have a single GPU, and this will basically tell the trainer or the PyTorch Lightning that we are going to actually use a GPU. So this will be very useful. And to initialize this, you can see that we have an available GPU, and this GPU is going to be used by the trainer. So next, what I have is a warning rate finder. And to get this, I'm going to call the tuner property. So this is another object from within the PyTorch Lightning. And I'm going to ask the tuner to find a warning rate for us. I'm going to pass in the model and the data module. And here you can see that you can also pass the train data loaders or other data loaders. But in our case, we have a complete PyTorch Lightning data module. So we're going to use this. And then the maximum warning rate, which is going to be the maximum warning rate that we specified. So this will create the finder and try to find the warning rate for us. So this will start the process. And during this time, we are going to, So this is telling us that the implementation of Adam with decay fix is deprecated. And we should use the Adam weight decay fix from PyTorch itself. So this is one thing that you might want to update in your code, and I'll make sure to update this into the Google Co-op notebook that will come with this tutorial. And you can see that the finding of the warning rate is very, actually very fast. This goes through, as I've already said, through a very small subset of the data. So the next thing that you can do, if we go to the documentation as well, is have a look at the results based on the finder, and then we can plot the suggestions of the warning rate. So let's go through this, and I'm going to specify our finder dot results, and once this is complete, we're going to look at those, and then I'm going to create a plot with the results along with the suggestions. So these are basically the warning rates that the model have tried and the different losses that we have. So this is very ugly to look at. Let's see how we can show the results in a plot. And yeah, as you can see, this is the number that is suggested by our warning rate finder. And actually, I've seen a lot of people, and especially Jeremy Howard from the deep learning courses. And this is actually the first place that I've seen this approach. And basically the best warning rate is some point at which the slope of this curve is pretty much maximum. So you don't want to pick a point right here or right here. So you want to pick something in the middle. And the algorithm that is provided by PyTorch Lightning does a good job of this. But to take the suggestion as a number, we have to call the suggestion. And this is the warning rate that is suggested by the warning rate finder. And I'm going to save this into a variable. And yeah, if I type this correctly, of course. So the new warning rate is going to be this exact number, and I'm going to basically specify the model warning rate. This is the property that we had to be this number. And this basically changes, the warning rate for the model that we have. So another thing I'm going to show you now is how you can basically integrate the PyTorch Lightning with TensorBoard. So to do that, I'm going to first load the extension TensorBoard in Google Co-op. And then we need a folder to which I'm going to point when the experiments are running. And to do that, I'm going to create experiments dir. And another thing that I'm going to use from PyTorch Lightning is the model checkpoint. We've already imported this, or not, obviously not. But yeah, Google Co-op is smart enough to show us how you can do this. And I'm going to pass in the file name of the checkpoint. And here I'm going to specify a syntax which is going to be used for saving the model file name or choosing the model file name. I want to save the last model or checkpoint and the top 3 models as well. I want to monitor the validation loss on each epoch, and I want this to be the minimum. So the best model is going to be the one with the minimum validation loss. Then I'm going to create the logger, and the logger itself is going to be the one that is saving the logs to TensorBoard. Logger. TensorBoard. Logger. And the directory is going to be the experiments here. And the name of the experiment is going to be emotion classification. And yeah, I need to import from PyTorch Lightning Wogger's TensorBoard Wogger. All right. So if we run through this, we have the checkpointing and then the TensorBoard Wogger, which are going to be useful when training the model. Then I'm going to start TensorBoard and I'm going to specify the experiments directory, which, yeah, failed to launch TensorBoard. Let me have a look at why this might be. So the problem was that we have, our TensorBoard is actually using a library called Markdown, which was basically the incorrect dependency right here. So to fix this, I looked through GitHub and it was suggested that we can install the Markdown library with the specific version of this one. So it's 334. And when this dependency is installed, running again the command extension on TensorBoard gave us this. So the TensorBoard library or app has been launched successfully. So next I'm going to basically run through everything here. And to do that, I'm going to create a new trainer. I'm going to specify the default dir, which is going to be the experiments directory, then the number of GPUs, the max steps, which are going to be the training steps. Then I'm going to specify the precision, and we are going to use a 16-bit precision, which is going to be a really helpful because this will basically speed up the training process for free. So max training steps, did we do this? Oh, I didn't create this constant. So let's create it right here. Let's say 650. And I'm going to comment out this because we already created the model in the data module. Yeah. So let's continue with the trainer. So this will be the training steps. The validation check interval. On every 40 steps, we are going to basically check what is the validation accuracy. And for the callbacks, I'm going to specify the checkpoint callback. And we can also have a look at the warning rate monitor, but this will not be useful right here because we have a constant warning rate. And I'm going to, I'm going to use this. And for the Wogger, I'm going to specify our TensorBoard Wogger that we've already created. So this will create the trainer, which is going to be the real one that we're going to use to fine-tune the model. And again, this is using actually the warning rate that we've already created with found with the warning rate founder. And next, I'm going to start the training itself. So to do that, I'm going to code just fit on the trainer. I'm going to pass the model and the data module. So this will hopefully start the training process. So this is basically how the training looks like. So we are given a small summary with emotion classification directory in which we are going to save the experiments themselves. And as you can see, the training is pretty fast. We are getting some numbers right here in the progress bar. We have a global seed, which is the number that we specified during the set seeds of the PyTorch Lightning. So this is pretty much a validation that we did everything correctly. And as you can see, the model is currently training. So let's go to the TensorBoard and refresh this. Yeah, so we still don't have any data. I believe that the data is going to be hopefully somewhere. Let's check at the experiments directory. Yeah, we have the emotion classification, so everything looks all right. And we also have some checkpoints already. So this is running very well. So 650 steps are now complete. And as you can see, the training process has been halted. So this is what we expect. And if I go here and refresh the data, you can see that we now have everything here. And I'm going to remove the smoothing to give us some better graphs here. So you can see that we did a couple of epochs, around 7, and the train loss has been steadily decreasing during this time. So you might want to train even further the model. But let's have a look at the validation loss. So you can see that we've actually bottomed out, let's say, right here. So this will have some effect. So you don't basically have to train a lot this kind of model for this data set. And another thing that I'm going to show you is how you can use the trainer test and use the data module to run through the test dataset and have a look at the best checkpoint, as you can see here. So we have some was defined right here. So this is very good. And then we are going to continue by saving the model. So I'm going to have a look at the classifier. And I'm going to save this model and to have a look at what we have here in this directory. I'll have to install 3 actually. And once this is complete, we can have a look at the directory and what it contains. And as you can see, we have this config file and then the binary of the checkpoint. And if you're curious, let's have a look at the emotion classifier config.json. And these are basically the mappings and a lot of configuration files for the model that we have for the ELECTRA model. So this pretty much sums up the training part of the model. And in the next one, I'm going to show you how you can use the pre-trained checkpoint and create an API on which you can basically get a tweet text and classify it into one of the emotions that we have so far. So stay tuned for that one. Please like, share, and subscribe. And thanks for watching. Bye bye, guys.